Mathematical practice number 8. Look for and express regularity in repeated reasoning. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. This webcast will highlight Mathematical Practice 8. Look for and express regularity in repeated reasoning. So, to begin investigating mathematical practice number 8, let's consider some situations outside the math classroom. In the routines of our daily lives, it is helpful to look for and express regularity in repeated reasoning. This becomes an organizational skill that helps us to be more efficient with time management. For example, rather than having to remember every item that you will need to take to work each day, with experience, you can just pack your bag the night before and then grab the bag as you're leaving in the morning. Or, if there's a meeting that you regularly lead, through experience you can create an agenda that will work most of the time. This repeated reasoning has given you a shortcut. You do not have to plan each meeting from scratch, but can use an agenda as a type of formula for organizing the meeting. This type of thinking also works when shopping for groceries. Once you become familiar with your grocery store, you can notice the items that you buy almost every time, as well as the sections of the store where you find those items. While shopping, you are attending to the big picture of your progress through the list, while you are also attending to details, like finding the better buy on a particular item. All 3 of these examples show how we can look for and express regularity in repeated reasoning in order to make our daily lives go more smoothly. Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to look for and express regularity in repeated reasoning. I'll highlight 3 features of this mathematical practice, as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. When you work with mathematical practice number 8, you'll be guiding your students to notice patterns, watch for shortcuts or formulas, and attend to the big picture as well as the details of the problem-solving process. To encourage learners to notice patterns, you could ask them, what part of your process are you repeating? How is this problem like the one that you just finished? For example, at a lower level, students could notice patterns in the multiplication facts up to 10 times 10. They may notice that the multiples of 5 have a 0 or 5 in the ones place, or that the sum of the digits of each of the multiples of 9 is 9, or that the multiples of 4 are even. The purpose of this is to start to build an understanding of the rich web of numeracy patterns and relationships, and show students that noticing patterns is part of mathematical thinking. At a higher level, students could discover the properties of exponents. In small groups, you could ask students to complete sample problems and then try to write a shortcut for reaching the answer. In this case, they may think, when terms with the same bases are multiplied, it looks like I can just add the exponents. They may then wonder what the shortcut will be when terms with the same bases are divided. You could explain that in this case, the shortcut is called a property. Students will take more ownership over a rule that they have discovered, and again, you will be training them to watch for patterns or shortcuts as they work through problems. By encouraging learners to notice patterns, you'll see them take a more metacognitive approach to problem solving. As they work to solve the problem at hand, they will also be noticing when repetition or patterns emerge. Now let's continue to the second feature. To encourage learners to watch for shortcuts or formulas, you could ask them, will it work this way every time? Could you use variables to write how it works in a general way? At first, these questions may seem mystifying to students, but with practice, they will be able to think about generalizing math processes or relationships. For example, multiplying the length and width of any rectangle is a way to find its area. At a lower level, when being introduced to fractions, students could notice that any fraction that has an equal numerator and denominator is equal to 1. Once they have discovered this, they will be able to generalize the concept with less common numbers or even variables. They may ask, is 17/17 equal to 1? You could challenge them by asking what needs to be in the denominator in order to make this equation true. The formula or shortcut that the student has noticed is that in a fraction, any value over itself is equal to 1. Guide your students to understand this conceptually, but from there, students can generalize the concept into a formula. At a higher level, when working with perimeter, students may notice that the formulas look different, but are actually 3 different ways to instruct the problem solver to add the lengths of all the sides of the figures. Rather than needing to know each formula, they can take the shortcut. To find the perimeter of a shape, simply add the lengths of all of the sides. By encouraging learners to watch for shortcuts or formulas, you'll find that you will see them watching for rules that they could apply in new situations. The third feature of looking for and expressing regularity in repeated reasoning is attending to the big picture as well as the details of the problem-solving process. To encourage this, you could ask, what is your goal? Which step are you on? And also, what are some things to be careful about? For example, at a lower level, students could attend to the big picture as well as the details as they subtract fractions and have to regroup. There are many steps to this process. In the big picture, students need to think about whether or not they need to regroup, and at the detail level, they need to remember the steps to accurately perform that process. At a higher level, students would need to be able to attend to the big picture as well as the details as they solved a system of equations. At the big picture level, they would need to choose a process. If choosing elimination, they would need to remember the goals of first using algebra to eliminate one variable and then isolating the remaining variable, all while they are being careful about the details like the signs of the numbers and accurately using the distributive property. By encouraging learners to attend to the big picture as well as the details of the problem-solving process, you'll see them take ownership of problem solving rather than relying so much on memorized steps. Each of the previous examples illustrates how students could look for and express regularity in repeated reasoning. Now let's watch these middle school students look for and express regularity in repeated reasoning as they try to identify proportional relationships.
Okay, if I could have your attention, we're going to get started. Yesterday, we looked at some situations similar to the ones that we have been looking at throughout this whole week and a half of instruction. So today, we're going to look further into those things, and hopefully, it's going to help you work through your thinking Today's lesson is about determining whether relationships are in proportion or not. They're in a proportional relationship or not. The first thing we did was look at a problem together of a proportional relationship.
10 ounces of cheese costs $2.40. Ross wants to buy blank ounces of cheese. Ross will have to pay blank dollars.
So 10 ounces of cheese costs $2.40. I want you to come up with some numbers that'll work there on your whiteboard. Just one set. And I asked them, is this a proportional relationship and why? To kind of get them in the frame of mind as, if I'm looking at two quantities, how do I tell if they're proportional? What can I use?
Multiply 0.24 because every 10 pounds is 2.40. So if you divide it by 2.40 by 10, then it's 0.24 to get 1.
Is the relationship between the ounces bought and the total cost a proportional relationship? Yes. Kelly.
It forms a straight line if you graph it
How do you know?
because you continue to go up and over by the same amount.
So you're going up over 1, up.
0.24.
I love it. So we got this. So that's what we're going to do today. We're going to look at a bunch of proportional situations and look and see if we think that they're proportional, okay? I handed out the card sets and said, with your partner, you're looking at two quantities and you have to set, they had to set the parameters. Here are the rules for working on the cards with your partner. Choose one of the cards to work on together, and you're going to choose some easy numbers to fill in the blanks. You're going to answer the question you have written and write all of your reasoning on the card, working together on this. Then you're going to choose harder numbers to fill in the blanks and answer your new questions together, writing all your reasoning on the card. Decide whether the quantities vary in direct proportion or in proportion. Write your answers and your reasoning on the card. When you have finished one card, you're going to choose another. Okay, you can begin with your partner.
So 50 times 1.575. Okay, that checks.
2 slices of toast in and I push down the buttons at the same time. When does the toast pop up at the same time probably? Okay, what if I put 1 slice in?
It'll pop up after 4 minutes.
So it's faster if you only do 1?
Oh, I get what it meant.
Does that change how you're thinking about it?
Yeah.
Okay, talk about it. You didn't have an all moment there. You were just like, huh?
Yeah, I was.
Well, when you guys talk, involve Matthew in the conversation, if you would.
It would still be 8 minutes. No. It would still be 16.
You order 4 times, and each of them is 5, so it's 5, 10, 15, 20. But each of them is $2, so it'd be 2, 4, 6, 8, and that's why I times it by 2.
What's my cost going to be for 10 minutes?
$7.50.
But you're forgetting about they're charging $5 per month.
So do you want us to add that on?
I do. You have to because you're going to get charged. I like the work. I thought that was nice. I would like to see you do some of the hard numbers.
Right.
Okay, so maybe switch roles. But now you have to say, is this a proportional relationship?
Okay.
To wrap up for today, maybe you didn't get through all of them, and that's okay because maybe we're all at a different level. That's fine. The takeaways from today were they're starting to figure out what the quantities are. They're starting to say, what's the relationship and how am I going to check this?
How did the students in the video demonstrate that they were looking for and expressing regularity in repeated reasoning? Did you see them notice patterns? Did you see them watch for shortcuts or formulas? Did you see them attend to the big picture as well as the details of the problem-solving process? All 3 features may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The students in the video were asked to analyze scenarios to see if they contain quantities that were proportional. Identifying proportional relationships at a lower level could be done by working with multiples of a number. At a higher level, students could find or create proportional relationships with linear equations and their graphs. Look in the college and career readiness standards for adult education to find the level that would work best in your class. In conclusion, I want to share a poster that summarizes Mathematical Practice 8. The next slide shows the link where you can download the poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to look for and express regularity in repeated reasoning?